In this video, we're going to look at the law of cosines. So if you can, recall cases 3 and 4 for solving oblique triangles. We talked about these when we looked at the law of sines, and just to remind you what those were, they were the cases where we had two sides and an included angle, so we were looking at a side angle side, or the fourth case was when we had all three sides, and we called this the side, side, side. In these cases, we don't have enough information to set up the law of sines. So in the first one, if I look at side angle side, and I label these A, B, C, we can see that I have side C and side B and angle A. And so I don't have a full proportion, and I can't set up my law of sines. In the case of side, 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 it doesn't even matter if I label these. I don't have any of the angles. So again, I'm not going to be able to set up any of the proportions. So if I am given a triangle ABC, then the law of cosines is what we're going to use to relate the sides of the triangle to one of the angles. Okay? It actually uses all three sides, so even if I don't know one of them, I'll still be able to solve for that side if I have the included angle. So the law of cosines says in triangle ABC, a squared is going to equal b squared plus c squared minus 2bc cosine of a. B squared is going to equal a squared plus c squared minus 2ac cosine of b. And c squared is going to be a squared plus b squared minus 2ab cosine of c. You do not need to remember all three of these law of cosines because, as you can see, the formulas are very similar. So if you remember which side length you're solving for or which angle you have, you can set it up accordingly. Okay. The other thing to keep in mind is this is a generalization of the Pythagorean theorem. In other words, the Pythagorean theorem is a specific case of our law of cosines. So for example, if I look at the last equation, c squared is equal to a squared plus b squared minus 2ab cosine of c, what you'll notice is if my c is a right angle, then the cosine of c, or cosine of 90 degrees, is 0. And so that last term, the 2ab cosine of c, goes away, and I'm just looking at c squared equaling a squared plus b squared, which is exactly our Pythagorean theorem. One of the things we're going to use the law of cosines for is to again solve triangles. Again, the main difference is the information that we start with. So in this example, let's solve the triangle ABC, where angle A is 108 degrees, side C is 18, and side B is 15. So here, because I have angle A, I can use the law of cosines to find side length A. So using this formula, I'm going to start by plugging in the values we know. Again, in this example, you're probably going to want to use a calculator, mostly to get the cosine of 108. Okay. So we're going to square the first two terms and then subtract off that last term. So a squared is going to equal 715.8692. Now again, there's more digits to this. And eventually we want to round it to 2 decimal places. So we want to take it a little bit further out because we're going to have some approximations in there. If you can leave the numbers in your calculator until after you take the square root, you're going to have a much more accurate answer. And in this video, even though I'm writing only 4 of the digits down past the decimal place, the answers are calculated using the exact values. So here, taking the square root, we get that A is going to equal 26.76. Okay. To get angle B, we can again use the law of cosines, except now we're going to use the second form, which is using the cosine of B. And we're just going to rewrite it. So instead of solving for B squared, we're going to solve for the cosine of B. So solving for cosine of B, we get this equation. Now we can plug in our values and take the arc cosine. Again, you'll need to evaluate this with a calculator. So again, you're going to want to square the values in the top and do the subtractions there, divide out by the total value in the bottom, and then take the arc cosine. Again, make sure your calculator is in degrees. When we do that, we find that B is going to equal 32.21 degrees. So all that's left is to find angle C, which now we have two of the three angles. So we can just subtract from 180. So angle C will equal 39.79 degrees. Okay. Now that we have all side lengths and all angles, we have solved the triangle. One thing to note in this problem is after we found side length A and having its corresponding angle, we can actually use the law of sines to finish solving the problem. Okay? The law of cosines is needed only to get that other piece of information so that we actually have enough information to solve the rest of the triangle. And once we have that initial piece, then it doesn't matter whether you use law of sines or law of cosines. Either one would work out. So again, to begin this, we need to find at least one of the angles so that we can use the law of so that we can solve for the remaining angles. To do this, we need to use the law of cosines. And it does not matter at this point which angle you pick because, again, you have all three sides. So pick whichever angle you'd like. I'm just going to go ahead and start with angle A. So here we can see that cosine of A is going to equal 122.5 squared minus 60.1 squared minus 154.6 squared divided by negative 2 times 60.1 times 154.6. And again, this is just using our cosine, our law of cosines, the very first equation rewritten in terms of the angle. Okay. To solve further, we're going to take the arc cosine of this. Plug this into the calculator and we can see that angle A is going to be 47.7 degrees. Now, as I mentioned after the last example, once I have one full ratio, meaning an angle and its corresponding side length, I don't necessarily need to use the law of cosines anymore. At this point, I can use the law of sines. And so here I have the information for both side length A and angle A, and to find B, I know the side length for B. So I can plug that into the law of sines and find the angle B. So sine of 47.7 divided by 122.5 is going to equal the sine of B divided by 60.1. So B will equal the arc sine of 60.1 sine of 47.7 degrees divided by 122.5. Again, plugging this into the calculator, we will see that B is going to equal 21.28 degrees. Lastly, to find angle C, we can just subtract because we now have two of the three angles. So subtracting from 180 will give us our value for angle C. So angle C is going to be 111.02 degrees. A nice application of the law of cosines involves finding the area of a triangle using the length of the sides. So if I'm looking at a side-side-side triangle, then I can find the area even though I don't have the base and the height. Okay? In other words, it's not a right triangle. But as we saw before, the law of cosines is a generalization of our Pythagorean theorem, which means I should be able to use some of the values that we get from right triangles, or some of the properties from them, to get the same properties for oblique triangles. And what that means in terms of the area is if I know the semi-perimeter, which is basically the perimeter divided by 2, I can find the area of the triangle without necessarily knowing what the height is that's perpendicular to the base. So here, if I have a triangle ABC, then the area is going to be the square root of the semi-perimeter times the semi-perimeter minus each of the side lengths, A, B, and C. This again is one of those formulas you're going to want to know for this course, but also for some things that you're going to do in later classes. So here let's find the area of triangle ABC, where we're given that A is 9, B is 12, and C is 15. So to find the area, I need to start by finding the semiperimeter. So again, the semiperimeter is going to be the sum of the sides, so 9 plus 12 plus 15, all divided by 2. So in this case, it'll be 18. Once we have the semiperimeter, we're just going to find the difference between it and all of the sides. Now that I have all the pieces, we can find the area. So plugging into our area formula, we see that the area is going to be the square root of 18 times 9 times 6 times 3. Now for this, again, you can plug into a calculator, but again, this is one of those properties that you should be able to simplify. And you'll notice the numbers here are not too bad. We can factor these down, and you'll notice that you get 3 to the 6th power times 2 to the 2nd power when you factor. And so simplifying the square root of that is going to be 3 to the 3rd times 2, which is going to equal 27 times 2, or 54. So there's the area of our triangle.